Hello, my dear students, and welcome to this session. Do I need to tell my name? My name is Anoop Vashishtha, and today we are going to do a very important topic, a small important topic, and hopefully we are going to finish it off right away. So today itself we are going to finish off with this topic, and the topic is what we call as metallurgy. Now it is also has a complete name in NCERT, that is General Principle and Process of Isolation of Elements. That is a super marathon session that we are having today. What I'm going to do is I'm just going to provide you with the NCERT of metallurgy. Okay, we'll upload the notes also. Okay, so we have Durga Prasad, Prerna Rajput, Tirthraj Mukherjee, Faiza Khatun, welcome, Radhika Mittal, Ananya Sarkar, and our we are every very own Ritik Prasad once again. So, what I'm going to do at this moment is that I am going to provide you the NCERT book on our own channel on Telegram group, and that is the group called which one? Anoop NEET English. I believe you have all joined that particular group. Here we have it. The chapter number 6. This is the chapter number 6, isn't it? Isn't this the chapter number 6? So joined with the group called Anoop NEET English. And here it is, NEET Anoop is the. I am now joined this group. Tirthraj Mukherjee joined this group. And you can join the WhatsApp group also. So we are going to talk about the WhatsApp group also. I have sent you the book on the WhatsApp as well. मैंने हिंदी की बुक भेज दी गलती से. Jyotiraditya Vara, the code is AVLIVE. Got the PDF? Great. So let's begin over with this chapter. That's metallurgy. Now this is what we have as batch, and the code you can use is either you can use the code WS Live or you can use the code AVLIVE. So you can use the code AVLIVE and join with us. Is this clear? So this is what we have as batch. We are going to start it right on 16th of August. So this is what we have as Swati ma'am, chemistry, and Sachin sir. This is what we have as Elixir dropper batch. You can join with it, and these are the yeah, these are the pages that you need to learn. So here it is me. So let's start over with a chapter called metallurgy. Now this chapter is not a very big chapter. This is a small chapter. This is easily understandable chapter. So let's get along with it. Anything you want to ask, you can go ahead and ask it. We will be able to finish off this chapter hopefully today itself. Okay? Don't worry about it. Not a difficult one, not a calculation, understanding and all the questions that you want to ask. So you can just ask me the questions. So we have the general principles and process of isolation of elements. Now there are minerals. Now we have the question called minerals. What are the minerals and what is an ore? Please remember anything which can be extracted from earth, whichever is obtained from earth is a mineral, whether it be soil itself, whether it be oil getting from the soil, mitti ka tel, that is again a mineral, we call it a mineral oil. Coal is a mineral. Now, anything which we obtain from the earth crust is what we know as a mineral. What is an ore? Ore is a naturally occurring solid material from which a metal or valuable mineral can be extracted profitably. Now, the word profitably is most important. So, if it can be obtained profitably, then it is a mineral. If it cannot be obtained profitably, it is not a mineral. Is this clear? So, that is what we have as a mineral. Good evening, everybody. Yes, we have begun. So, these are the few minerals that we talk about: chalcopyrite, boronite, azurite, chrysocolla, malachite, cuprite, copper. These are the minerals. Is that clear? Okay, so that's what we have understood the ore. Now, there are seven metals of antiquity. That is, nobody knows who discovered these metals. Clear? So, that is what we call as metals of antiquity, where so we talk about the metals of antiquity. Okay, no one knows who discovered them. And what are those? Gold, copper, silver, lead, tin, iron, and mercury. Now, iron was discovered much later. Iron and tin were discovered much later. Gold, copper, silver, lead, mercury, they were discovered much earlier because these metals are much less reactive. So, extraction of these metals was quite easy. And that's what we are going to do in this today's chapter. We are going to understand which metal can be extracted easily and which metals are difficult to extract. Now, carbon, sulfur, gold, noble gases occur in free states, while carbon, why does it occur in the free state? Because of the existence of diamond, graphite, which are quite inert, and further the coal, which are because of the biological functions. Okay. So amongst metals, aluminium is the most abundant and third most abundant element. The first one is oxygen in the earth crust. Second one is silicon. Third one is aluminium. And iron is the second most abundant metal. Clear? And when we talk about metals, we look for the minerals, that is ores, which are naturally occurring chemical substances in the earth crust and are obtained through mining. So minerals are obtained by mining. Where we can get obtain the metals profitably, they are called ores. Now, the entire scientific and technological process used for isolation of the metal from its ore is called metallurgy. So this is what we call as metallurgy. Now, what are the steps in metallurgy? The very first step is concentration. Concentration of the ore is also called beneficiation. It is also called ore dressing. Okay. सर आपने रैंक प्रोड्यूस की है चिंटू भाई मेरी तो रैंक नहीं आई थी but I believe I have produced all the ranks. I have produced the first rank, the last rank. I have produced the first ranker of AIMS, of IIT, of DPMT, CBSC. I don't know how many ranks I have produced. I have been teaching for past 26 years. But please remember, rank is not produced by the teacher. Rank is obtained by the student. Okay. ठीक है चिंटू भाई आंसर मिल गया आपको So now the first is ore beneficiation, ore dressing. And then we isolate the metals from the concentrated ore. Then we purify the metal. So these are the three steps in metallurgy. Now, the very first beginning of metallurgy is that we mine the ore and transport it. Now, it all depends what kind of ore it is and what kind of facilities we have. Many a times the ores are mined and transported through the ships to the different countries even. Like Japan buys the ores, iron ore from India. So many of the ores are mined in Goa and they are transported to Japan. And many a times the industries are set up around the mines, like in Bihar. Bihar, the ore is mined, the Jharkhand ore is mined there, and it is being utilized right there in the various mines, the various industries. Teeraj, beta, it all depends on what the questions are asked. What do you think? In these 26 years of career, nobody would have asked me such questions. Many people. Okay, so that's what we have as ore. Now they are mined, they are transported, and then they are processed. Ore beneficiation, mostly it is done right at near the mines. It is not transported. Beneficiation के बाद ore को transport करते हैं because lot of mass is reduced, so it is better to transport the ore. Okay. Once we have taken the ore, now it is crushed. We can call it crushing or grinding of the ore. There are stomp mills, there are huge mills which crush the ore. Now that is necessary because we need to remove the various impurities from the ore, and so it is shaken, it is removed, and then it is sieved. So the loose impurities are removed from the ore, separated out. Now it is a preliminary, very, very preliminary treatment. It is not even the beneficiation of the ore. Here we have not even started with the beneficiation. But the thing is, it's something like कि अगर आपके चावल में एक पत्थर बड़ा सा पत्थर रखा हुआ है तो आप चावल धोने का इंतजार नहीं करते यू जस्ट पिक इट अप एंड थ्रो इट आउट नहीं हम तो छन्नी से निकालेंगे पत्थर छन्नी से नहीं निकलेगा सो whatever impurities can be removed at any stage we do it more the impurities are removed less is the cost involved in refining of the metal extraction of the metal and metallurgy is all about industry. It is all about economics. Is that clear? So that is what we get. Clear? So now we are going to purify the metals. So let's begin over the purification. The removal of the unwanted materials, that is sand, clays, rocks, unwanted rocks from the ore, organic material, plant material from the ore is termed as concentration ore dressing or ore beneficiation. Is it clear? So I hope you like it. Now the very first concentration method is called hydraulic washing. Now hydraulic washing, as the name itself suggests, it has to deal with water. So something to do with water. Clear? It is based on the difference in the density. Now, you can very well check the hydraulic washing at your home as well. Take a bowl, any container, put some sand in it, मिट्टी, पार्क में जाके मिट्टी उठा के इसमें डाल देना. And then take it into a sink or maybe some outside if you have some tap out of your house because the मिट्टी जब बाहर निकलेगी तो हो सकता है मम्मी आपकी पिटाई कर दे. तो just be careful कि ज्यादा गंदगी मत करना. And then you allow the water to fall into it from the tap. टैप थोड़ा तेज चला देना. जैसे ही आप तेज चलाओगे, you will find ये मिट्टी पूरी बाहर निकल गई है. ठीक है? थोड़ी देर टैप चलाना, the water is going to become clean and you will find small stone pieces lying inside. Rest of the things are going to move out. It will be washed, it will be clean water. Now, this is what we have as gravity separation. This is also called levitation. And it's all dependent on the things like density. नहीं चिंटू भाई, इसके नोट्स बनाने की जरूरत नहीं है. आप एनसीईआरटी मैंने आपको भेज दी है, आपके पास एनसीईआरटी की बुक है, उसी में मार्क करते चले जाओ, उसी के अंदर आप छोटा छोटा एनेक्डोट्स लिखते चले जाओ. इस चैप्टर के नोट्स बनाने की जरूरत नहीं है. Okay, because this chapter is going to be exactly from the NCERT. Line by line, whatever comes will be from NCERT. Nothing else, nothing more, not much to even understand. Okay, but if we feel कॉपी में एक दो पेज के नोट्स बना लो तो बहुत है. एक दो पेज काफी होंगे. ओके, रेस्ट आई एम गोइंग टू अपलोड दीज नोट्स. यू कैन गेट इट. एनसीईआरटी बुक आपके पास है, बट नोट्स के अंदर जो है वो एनिमेशंस दिखाई नहीं देंगे. ठीक है, एक काम करता हूं ना कि मैं आपके ये जो नोट्स हैं वो पहले ही अपलोड कर देता हूं व्हाट्सएप ग्रुप पर. Okay, so this is based. See, this is what is important you have. You need to know the basis of each based on the difference in the density of the ore and the impurity. Ores are heavy, so this method is used for heavy ores, something like iron ore, tin. This is what we use, and this is a preliminary method. Okay, this is another way of depicting it. We have the spray of water, it moves down, and we get the soil, the mitti, the gang down. चिंटू भाई ये डिलीट हो गया है तो क्या कर सकते हैं? चिंटू भाई, यू आर नॉट सपोज टू कमेंट. आपको किसी पे कमेंट नहीं करना. एंड दुर्गा प्रसाद, आई एम टीचिंग इन इंग्लिश. व्हाट्स द प्रॉब्लम? It's written in English. I'm teaching in English. If I say one or two words of Hindi, that doesn't make a problem. Okay. I'm explaining in English only, and this is an English medium channel. So based on the difference in the density, now this is sometimes referred to as the Wilfley's table. The spray of water will take away the lighter impurities down, and this is what we are going to have, the pure impurities. Absolutely pure impurities. Is it clear? The notes have been provided even before the class right now. Okay. Where am I taking live classes? From my own studio. You are having the classes right from my studio. Okay. So based on the difference, this is what we have as metallurgy. This is what we have as gravity separation. Now we have the magnetic separation. Quite obviously, magnetic separation is based. It is based on the difference in magnetic properties. Clear? This is based on the difference in magnetic properties. Now, what has happened is when we talk about this particular roller, this roller, this is non-magnetic. This one is non-magnetic. Now, this roller is magnetic. Out of that, the red particles are magnetic particles, while these green or blue particles, whatever that might be, they are non-magnetic. So what happens is that non-magnetic particles, since this roller is moving very fast, fast moving roller. This roller is moving quite fast. Okay. When this roller is moving quite fast, what happens is that this green ones, which are not attracted by the magnet, they move farther. वो दूर गिरते हैं, देखो यहां से वो दूर गिर रहे हैं ना, बहुत दूर गिर रहे हैं ये, तो ये दूर गिरते हैं, ठीक है. And this one, the red ones, which are magnetic, they stick to the magnetic, they fall nearer, and rather I should say, they move backwards. And that is how we are able to separate the magnetic and non-magnetic separate. Okay, so that is how we are able to separate the magnetic and non-magnetic materials. Is it clear? So that is what we have as magnetic separation. Now, these are not actually used to separate the impurities. These are mainly used to separate the different ores. The same source could be having two different ores. Maybe there is iron ore also present in it, and maybe there is the ore of lead also present in it. Then in that case, the lead and iron can be easily separated using magnetic separation. Clear? Now we talk about something called electrostatic separation. Now, this is based on the difference in the electrical properties of the ore and impurity. Again, that is used for the separation of different ores. Now, please remember, it is based on difference in conduction of electricity. Okay. The ore which is a better conductor of electricity gets charged. Clear? It gets charged. And it is getting attracted towards, or rather, I should say, repelled by the electric field. So it is based on the difference in conduction. Is it clear? That is what we call as electrostatic separation. Now we have a very famous method. And this very famous method is called the froth flotation method. Now, there is a word here which we term as wettability. Wettability. And let's understand what is the meaning of wettability. Now, what you do is you can take, again, you can do an experiment at your home itself. Take a small amount of sand, mitti, okay, and put a drop of oil in it. Make a paste. Fine. Now, oil is going to stick to the surface of the sand. Now, what you do is take a bowl of water, put the sand in it, and shake it well. You will find that the entire oil which was sticking to the sand that moves to the surface of the water. Okay, remove that sand or water and just touch the sand. You will find that there is no oil in it. The sand loses the oil. Sand has a higher affinity for water as compared to oil. And we say that sand gets wet by the water rather than oil. On the other hand, what you do is you just put some oil on your hand and you put your hand in water. You will find that oil sticks to your hand and water does not. Your hand has an affinity towards oil, not towards water. And that is why when we take a bath, we need a soap because soap is able to remove the oil from our skin. Otherwise, oil sticks to our skin. Okay. Ananya, we are taking too many classes, too long classes on YouTube. Okay, fine. So you have the special class right today. I'll just create the special class. किसकी कराएं? Solid state questions? So, solid state has been created today, 8 p.m. It has been shared with you on the WhatsApp and the Telegram channel. लो जी, लग गई आपकी स्पेशल क्लास भी. Okay. So we have the froth flotation process. So let's get along with the froth flotation process. Okay. Durga Prasad, link is already there on the group. Join the group. Just send a message on this particular number. I'll send you the link of the group where you need to join. Saurabh, there are 13 likes now. Saurabh Karode, 13 likes now. So like it, like the session. And now we are getting along with what the froth flotation method is. Now this is what we call as the wettability of the ore. That what the ore has an attraction to, whether it is attracted to the sand, soil, or is it attracted to the water. Okay. Now, what we find is that the sand, the impurities have a more tendency to get attracted towards water. All the ores are minerals, but all minerals are not ores because anything we extract from the earth is a mineral. Okay, but the ore is a mineral from which we can extract a metal profitably. So all ores are minerals, but all minerals are not ores. Now, what we find is that the impurities have a higher tendency to be attracted by water. So impurities are weighted by water, while the ore is weighted by the bipolar substance. Now, those bipolar substances could be pine oil, fatty acids, xanthates, detergents. Now, these are able to extract the ore. These are able to stick to the ore. Now, when we talk about the ores, when we talk about the froth flotation process, we find that mostly we talk about the sulfide ores. Please remember, it is not necessarily only the sulfide ores. The other ores would also be extracted, but the sulfide ores are used because here we are talking about copper. Sulfide का खास बात क्या? What is important about the sulfide is that sulfide ion is large. More is the size of the anion. More is the polarizability of the anion. So more is the size of the anion, more is the polarizability of the anion, and more is the polarizability of the anion, more is the covalent character. Okay, is it clear? It is the all that is more is the covalent character. Now, when we have more covalent character, then it is more attracted towards non-polar solvents. When we talk about any of these pine oils, fatty acids, xanthates, they all are long chain compounds where we have a head which is polar and tail which is non-polar. All they have this thing common. So it is all are going to be something like this. This is going to be the chain and there is going to be the head which is going to be polar. Is that clear? So that is what we have as the collectors. Now when the froth is being formed, we need some froth stabilizer. आपको पता है कि साबुन का जो झाग होता है वो बहुत स्टेबल नहीं होता. So we need some things to stabilize that froth. And this is what we have as cresol, we have aniline which stabilize the froth. And then we have depressants and activators to separate the different ores. Okay. Depressants are going to suppress certain ores and they prevent that ores from going out with the froth. And activators are something which are going to activate some ores to move out with the froth. So depressants and activators are used to separate the ores. Is that clear? So that is what we have as the depressant and activators. We are going to talk about them also. Clear? Now this is what we have as froth flotation chamber, a good diagram. This is what we have as the stirrer. Now stirrer rotates and it is a hollow stirrer from where we put in the compressed air. This air moves in and there the bubbles are being formed. So the froth is created here. Okay. Here we have added the ore. This is ore, water, pine oil, detergent, xanthates, anything which we can put in here. Okay. Polarizability. Polarizability is the deformability. The ore, the molecule can be deformed. That is what we call as polarizability. Okay. Like we have a big particle. We have the big particle. We put a charge here. It gets deformed. It goes like this because the positive charge is going to attract it. This deformation of the electron cloud is called polarization. And more easily a species can get polarized, it is called polarizability. Clear? Durga Prasad, is it clear to you? Now, so that is what we have as the froth flotation. Now, when the froth is being formed, the ore particles stick to the froth and they move out from here. So froth is moved here. And then the froth settles down and the ore particles they deposit at the bottom. Here we remove the froth and we use it again. Clear? So this is what we have as the froth flotation. Is this clear? Okay. Now, when we talk about this froth flotation, when we talk about this froth, when we talk about this froth, now what happens is that we can have certain depressant. Depressant is sodium cyanide. Sodium cyanide. Now the cyanide ion has a peculiar characteristic that it is going to stick on the surface of iron and prevent it from going into the froth. No, it prevents zinc from going into the froth. So this is going to be called a depressant. And then we have an activator. This activator is copper sulfate. Copper sulfate prompts the substances to move out into the froth. Is it clear? So that is what we have as the depressant and activators which are used to separate the ores. Clear? Using the depressant and activator, we can actually separate the different categories of ores. Is this clear? So that is what we have as the froth flotation method and the basis of it. And now we are going to talk about the leaching. Okay. Talking about leaching. Now, leaching is also can be termed as solvent extraction. Leaching can be termed as solvent extraction, and this is based on the difference in solubility. It is based on the difference in solubility of ore and impurity in a specific solvent. Okay. Now, leaching is of many types. Many things are leached, many things are used in leaching. So let's understand what is all about leaching. Yeah. When we talk about the leaching, the very first process that we talk about is called amalgamation. Amalgamation. Now, amalgams are liquid alloys with mercury. Yeah. So amalgams are liquid alloys with mercury. When we talk about the liquid alloys with mercury, what are the various liquid alloys? What are the substances? Remember, metals dissolve in mercury. Now, which metals dissolve in mercury? That could be gold. Gold dissolves in mercury. Silver dissolves in mercury. Yeah. Like tin, lead, they also dissolve in mercury. But the important thing, platinum, tin doesn't dissolve. Platinum, iron do not dissolve in mercury. So mercury is actually stored in iron containers. Obviously, nobody is going to store mercury in platinum containers. People are going to throw off the mercury and take away the platinum. So platinum and iron, they do not dissolve in mercury. Platinum is used whenever we have to make the electrodes using mercury. Fine. That's what we have as the amalgamation. Now, amalgams. Now, what happens is gold being quite unreactive, it is obtained in the elemental form, but that gold is coated on the surface of sand. So we have golden sand from which the gold can be extracted by dissolving that gold in mercury. Okay. So that sand is scrubbed with mercury. Sand is scrubbed with mercury. Okay. And then it is distilled. Mercury has a boiling point of 360 degrees Celsius. Gold has a melting point of approximately 1000 degrees Celsius. So mercury is distilled off, leaving gold behind. And that is how we are able to separate gold. We are able to extract gold. And this is the process which we call as amalgamation. Clear? One thing is we have understood that if we have golden sand, we can use amalgamation. But what happens if we don't have golden sand, but we have very small amount of gold in the sand? Now, when we talk about the very small amount of gold in the sand, there we use a process called MacArthur Forest Cyanide process. One thing you need to understand, what can be the biggest misfortune of a piece of land? The biggest misfortune of a piece of land is humans find gold there. If we find gold at some place, we are going to destroy that piece of land and we are going to make it absolutely unusable forever. And what do we do? How do we make it unusable forever? We take that sand and we scrub it with sodium cyanide and oxygen. Okay. Let us say we have gold. We treat it with sodium cyanide in presence of oxygen and water. In presence of oxygen and cyanide, gold forms complex. It forms NaAuCN twice plus sodium hydroxide. Clear? Now, this equation is quite tricky to balance. So let me tell you how to balance this particular equation. Okay, so let's balance this particular equation. Oxygen shows 4 electron change and gold here is +1 oxidation state. So when we talk about this +1 oxidation state, this would mean that for this particular oxygen, 4 gold atoms would be required. If we require 4 gold atoms, then in that case, 4 NaAuCN whole twice will be formed. If we have 4 of this, then cyanide is going to be 8. If cyanide is going to be 8 and 4 sodium are here, then 4 sodium hydroxide would be there. We need 4 of hydrogens, so it is going to be 2 of water. Equation is balanced. Okay. Now the first step was the most difficult, where we talked about how much electron change is taking place. Gold goes from 0 oxidation state to +1 oxidation state, and therefore there is a net change of 1 electron per gold, and there is going to be a net change of 4 electrons in 4 gold atoms. Is this clear? Hello Ranjan, how are you? Is this clear? Okay. Now, when we have this 4NaAuCN twice, we treat it with zinc. Now, zinc is the reducing agent. Now, remember this reaction which we are doing is an extremely important reaction because this is one of the reactions which is given twice in NCERT. NCERT doesn't repeat anything. So if this reaction is given twice in NCERT, obviously this is going to be a very important reaction. Okay. This zinc becomes the reducing agent and we get twice of Na2ZnCN4. Okay. Plus 4Au. Now the same process can be used for silver as well. रंजन स्क्रीन ब्लैक कर दूंगा तो बहुत ज्यादा ब्लैक हो जाएगी. Now this is what has been given by Unacademy because Unacademy color is blue. Okay, so we have to follow that particular thing, so it can't be made black. So zinc is going to be the reducing agent. Fine. So this is what we have as MacArthur Forest cyanide process, and this process is used for gold and silver. Now, having talked about this process, MacArthur Forest cyanide process, which is used for the leaching of gold, sometimes what happens is we have copper and very poor ores of copper. So when we have very poor ores of copper, the froth flotation process is not economical to be used there. And if it is not going to be practical to use this ore here, what we do is we use a different method. What's a different method? We have the entire mold mountain of the ore. Okay, this is the ore. And there we put a sprinkler. Okay, at the top, a sprinkler at the top. That will keep on sprinkling the water on it. Now, please, if you find this sprinkler, don't go and take a bath in it because this sprinkler contains dilute sulfuric acid. Most often, ore exists, the copper exists as copper carbonate, maybe copper sulfide, copper sulfate. Now, dilute sulfuric acid is able to convert those into sulfates. They move down, and there are channels here. These channels go into a container. Now, this container contains scrap iron, copper sulfide, Cu2s, Cus, they react with H2SO4 to form CuSO4, which is soluble in water. This CuSO4 reacts with iron to give Cu plus FeSO4. This FeSO4 is used to make moher salt. So we don't waste it. Is this clear? Anybody who has not liked the session, go ahead and like it. So we get moher salt, and that is how we extract copper from poor sources of copper. Yeah. That was the extraction of copper. And now we are going to talk about a very, very famous method, and that is called Bayer's process. Bayer's process is for refining or for purification or concentration of bauxite. When you talk about bauxite, bauxite is actually aluminum oxide. It is Al2O3.XH2O. It is hydrated alumina. And remember, bauxite is hydroxide as well as oxide. It is actually AlO.OH4. It is hydroxide, oxide, and hydrated ore. So that is what we have as bauxite. Now, bauxite contains certain impurities. It contains silica as an impurity, aluminosilicate, silica, and it contains iron oxides. It is Fe2O3, FeO, all mixed oxide. Now, this is sometimes referred to as red bauxite. This is referred to as red bauxite. Now, we treat this bauxite with one solvent, and that is dilute hot sodium hydroxide. Dilute hot sodium hydroxide. Now, when we talk about Fe2O3, there is no reaction. It does not interact with the sodium hydroxide. So there isn't any reaction, and this separates out. Okay, no problems. Now, silica is going to react with sodium hydroxide, and it is going to form Na2SiO3. sodium silicate, and it's soluble. Okay. In the same manner, aluminum oxide is going to react with sodium hydroxide to form NaAlOH4, which is sometimes referred to as NaAlO2, and this is NaAlO2 is called sodium meta-aluminate. This is called sodium meta-aluminate. Any confusions? Now, if I pass carbon dioxide through it, if I pass carbon dioxide through it, we acidify it. On passing carbon dioxide through it, Al2O3 dot XH2O precipitates out, which on igniting, that is heating strongly, gives Al2O3, which is called alumina. This is unaffected. Silica does not precipitate out. So that is how we are able to get alumina. And this is what we have as Bayer's process. Anyone has to ask anything here? So here we talk about leaching. It's a widely process used in extractive metallurgy where ore is treated with chemicals to convert the valuable metals into soluble salt while impurity remains insoluble. Okay. We can leach oxides, water, sulfuric acid, ammonium hydroxide, and everything. Now here we talk about something called amalgamation. I've already told you what amalgamation is. But that causes poisoning. Is this clear? Anybody who has not liked the session, please like it. So we have just done the MacArthur forest cyanide process. Any confusions here? And this is the sprinklers, the very rare or very poor source of copper. Any confusions, anybody? Now, Bayer's process. These are the reactions of Bayer's process. Whoever has not liked the session as yet, go ahead and like it. Priyanshu has already joined the Plus course. Yep, he has joined the Plus course. Okay, I think this question is easy to answer. Sadia, how are you? I hope you are able to understand it now. We are talking about inorganic chemistry, which is most difficult to ratta. Yeah. Now, once we have converted the ore, we have extracted the ore, we have concentrated the ore. Now comes that we have to extract the metal from the concentrated ore. Now, most of the times, many of the times, the metal ore is converted into oxide. The question is, why do we convert it into oxide? Metal ores are mostly converted to oxide. Now, why do we need to convert it into oxide? The simple reason is oxides can be converted to metals by reduction with aluminium, carbon, silicon, or even hydrogen. Aluminium, carbon, silicon, and hydrogen have a very high affinity towards oxygen, and therefore they are capable of extracting oxygen from metals. Clear? So that is easy to use. And that is why we prefer to convert the metal ores into oxide so that these reducing agent can be used. Okay? So that is why metals are mostly converted to oxides. Now, when we talk about the conversion to oxides, we have the method to convert it. And to convert the method to convert it, what we call is the two methods are there, which is called calcination and roasting. So let's understand the calcination and roasting. Calcination involves heating in limited supply of air. In limited or restricted supply of air. Just understand it is air is enough to burn the fuel only. Is it clear? So it is enough to burn the fuel only, nothing more than that. Okay. What it is used? It is used to convert, it is used to remove water. और अच्छा हाँ, आज जो हमारे जो बैच के ऊपर ऑफर चल रही है ना, आज उस ऑफर का लास्ट डे है। तो पीयूष ने तो उसका बेनिफिट उठा लिया है, आप भी उठा लो तो अच्छी बात है। ओके, फाइन। जल्दी स्टार्ट हो जाएगा बेटा फिजिक्स की क्लास। तो एयर इज इनफ टू बर्न द फ्यूल ओनली। ओके, इट इज नॉट इनफ to oxidize. It is used for converting carbonate to oxide. Okay, we can convert carbonate to oxide. We can remove the water of hydration, and we can even talk about the conversion of hydroxide to oxide. So that is what we do with calcination. Okay, so that is what we have as calcination. And then we have the next thing called roasting. Now, this is what we have as the furnace. The furnace which is used for calcination as well as roasting is called reverberatory furnace. Reverberatory furnace has a peculiar characteristic that the flames and hot gases come in contact with ore but not the fuel. Okay, so fuel does not come in contact with the ore. The flames, hot gases, they come in contact with the ore. Is this clear? So that is what we have as the reverberatory furnace. Is this clear? Now, ore is heated below its melting point. It is not heated to the high boiling point, not to its higher melting point. Okay, so that is what we have as the refractory furnace. Clear? Now, there is then in the case of refractory furnace, we can always control the flow of air. So flow of air can be controlled in the refractory furnace. In this case, if we have the high flow of air, it is going to become roasting, and if we have low flow of air, it is going to become calcination. Okay, this is reverberatory furnace. Reverberation because here the flames are reverberated or reflected from the surface. NEET says, sir, you left something. But I am teaching you. That is the most important thing. Okay. There also I was teaching on YouTube. Here also I am teaching on YouTube. How does it make a difference? Welcome. Join this channel. I believe you have already joined my channel. You would be getting the information already. Did you not join the Telegram channel earlier? Yes, I take 11 classes also here. So now join the Telegram channel. Please somebody tell him the Telegram channel, or you can just give me the message on 7975441411. Say drop in a message. I'll give you the link of the Telegram channel. And there is a Telegram channel in the description also. You can join that Telegram channel as well. Okay. So this is what we have as reverberatory furnace. This is what we have as calcination. Okay. And we can talk about roasting also. Now, what is the difference between calcination and roasting? Roasting is in the free flow of air. The major part of roasting is to convert sulfide to oxide. So there roasting is used to convert sulfide to oxide. The प्लस बैच का से स्टार्ट हो रहा है. कब से स्टार्ट हो रहा है? प्लस बैच is going to start from 16th August. If you want to join the plus batch, specific plus batch that is done by Sachin sir, me, Swati ma'am, and the new physics teacher, you can join at a very discounted rate. That is specifically for these people. Okay, so go ahead and join with that particular plus batch, specific discounted rate. But better you start with today, join it today itself, because that will allow you to get the discount, and it will be valid for 30 till 31st of August 2024. So you don't need to worry about whether your examination would be before that or not. So you can just join it right now and use the code AVLive to join that plus course. Okay. So in roasting, the ore is heated to in a regular supply of air in a furnace at a temperature below the melting point of the metal. Some of the reactions, these sulfide ores. Now just remember, roasting is able to do all the things that calcination does. Okay. Roasting does all the things of calcination. But important thing is roasting requires more fuel. So it is a bit costly. Roasting is a bit costly because it requires more fuel than this. Is it clear? Roasting requires more fuel, and that is why it is costly. Okay. So whenever we have possibility, we do calcination, not roasting. Until else it is sulfide ores, we do not talk about roasting. Okay. Now let's talk about the conversion of the oxide to metal. Clear? Let's talk about the conversion of oxide to metal. Now, before we get along with the conversion of the oxide to the metal, I'll tell you a very simple thing. Very, very simple thing. In electrochemistry chapter, we talked about the cathodic discharge series. We are going to write that cathodic discharge series once again. Metals are going to be at the cathode only. So we are going to write the cathodic discharge series. Now, what is the cathodic discharge series? Late Professor BCS MAZI N T L. Here we have hydrogen and we have copper cup made of silver plated with gold. Okay. Now, this is what we have, the electrochemical cathode discharge series. Here, this is least reactive. Here it is most. Now, these metals, they are obtained in native state and may be refined. They may be refined. They are obtained in the native state and they may be refined. So plus batch तो बता दिया मैंने आपको और कुछ? Okay. So here we talked about the MacArthur forest cyanide process, maybe a little bit washing and then doing it. So platinum and gold are refined like that. Then when we talk about copper and silver, oh sorry, silver and mercury, these are decomposed. They're oxides. Oxides decomposed by heat. Here the oxides are simply decomposed by heat. Now an example of this part would be something like we have AgCl, silver chloride. Now silver chloride is heated with sodium carbonate. Now sodium carbonate is not a reducing agent. Please remember that. So here we are heating it with sodium carbonate. It initially forms silver carbonate along with sodium chloride. Now silver carbonate further decomposes to form silver oxide, which is easily decomposed to form silver. Okay. So here we do not need any kind of reducing agent. We simply need to heat it. In the same manner, we can have mercuric sulfide or mercuric oxide. Mercuric oxide was the one which was used to produce oxygen for the first time. Mercuric oxide was heated by using heat, by focusing sunlight over it, and that was used to produce oxygen for the first time. Now here we can treat it with oxygen and simply heat it, and we get mercury along with sulfur dioxide. So it is separated out easily. Mercuric oxide, HgO, Hg2O, just heat it and it's able to give us mercury plus half of O2. So here we do not need any kind of reducing agent. Is it clear? So that's what we have as these two. Here we have these lead and copper. Now lead and copper we use the process which we call as auto reduction. Lead and copper we use the process which we call as auto reduction. Now before we get any further to that, let's talk about certain terms. Okay. Then very first term, smelting. Smelting. Smelting is extraction of metal from ore by heating it in a furnace with a reducing agent and flux. Reducing agent and flux. That is smelting. And pyrometallurgy is something wherever we require a temperature greater than 500 degrees Celsius, that is termed as pyrometallurgy. Clear? So that is what we have as smelting. Having talked about smelting, now we call about something called the gangue. Some people call it gangu, gange, gang, gand, whatever you want to call it, gangue. Now these are the impurities present in the ore. Gangue is the impurities present in the ore. Then we have something called flux. An impurity which is deliberately added to during extraction. Okay. Now, what is the function of flux? The first function facilitates removal of impurities. Okay. In electrolytic extraction, reduces melting point of ore. And third, increases electrical conductance. That is the function of flux. And this is in electrolytic reduction, or you may call it extraction. So that is the use of the thing called flux. We have understood what is gain. We have understood what is flux. Okay. Now we talk about one more thing, and that one more thing is called slag. Okay. Slag is a fusible, मतलब कि low melting point, a fusible lower density substance formed by reaction of flux with gain. Any kind of doubts here? Okay. Great, Teetraj, you followed me on Instagram. I'll prefer all of you follow me on Instagram. But Instagram में मैं ज्यादा एक्टिव नहीं हूँ. अब मुझे एक्टिव होना पड़ेगा. मैं बहुत inactive हो गया हूँ. Now, fusible, low melting point, lower density substance formed at the reaction of flux with gangue, which floats on surface of molten metal from where it is skimmed off. स्किमिंग का मतलब क्या है? दूध के ऊपर मलाई होती है ना, वो मलाई निकाल लेते हो. That is called skimming. So it is also on the surface of the molten metal from where it can be extracted. Okay, so that is skimmed from the surface. Is it clear? That is what we have something called the slag. Now, slag also has functions. First, removes the impurities. That is gangue. Second, a very important function, prevents reoxidation of molten metal. Prevents reoxidation of the molten metal. It covers the surface of the molten metal, so oxygen and other gases are not able to react with the metal. Third, phosphate slag is used as fertilizer. Phosphate slag is used as fertilizer. Okay. Silicate slag is used to make glass. Okay. Other slags used as fillers in construction. That is making the roads. Okay, so there we use the slag, and that is the use of slag. Any confusion? Okay, let's have a break of 3 minutes. 3 minute break. Meet at 5:37. 3 minute break. ठीक है, मिलते हैं. So we are here. Buffering तो नहीं हो रहा. No buffering is taking place at this moment. Okay, so that's what we have as the purpose of the flux. Now we use a thing called auto reduction. Auto reduction also is known as bessemerization. Auto reduction is also known as bessemerization. Okay. Now let us understand what exactly is the meaning of auto reduction. Auto reduction is a process in which one part of the ore is the reducing agent while other part becomes the oxidizing agent, so that metal is extracted without the use of any other reducing agent. Okay, so this is what we call as auto reduction or bessemerization. Is it clear? Clear? Now, auto reduction is used for copper and lead sulfides. Let's do it. We have the bessemerization or auto reduction for copper, and it is being done in the reverberatory furnace, or you may call it Bessemer's converter. So, Bessemer's converter, reverberatory furnace. Bessemer's converter is actually the modern form of reverberatory furnace. So, what exactly is being done? Here we have the reverberatory furnace. यार ये अच्छा नहीं लगता ऐसे. A pear-shaped furnace. That is the reverberatory furnace. Okay. Here we have a platform, and here this platform has holes and it is having some cap like this. Okay. Here we have the fuel. Here is the opening for air. It's controlled. Here is the opening for molten metal. Here is the opening for the slag. Okay. Now, here the fuel is burnt, and here it is the opening for waste gases. Now, these waste gases are analyzed spectroscopically. So, we know its constitution. Is this clear? Now, what happens is initially it is free flow of air. Initially, free flow of air. Is this clear? I think we won't be able to complete the metallurgy in one class. Initially, it is a free flow of air. So what happens in the initial free flow of air? We have Cu2s. Okay. We react it with oxygen. And when we react it with oxygen, we get two things. We get Cu2O and we get SO2. Okay. Here we have 2C2O and here we have 3O2. Here we get 2Cu2O and 2SO2. Is this clear? Now this is the oxide part. We let 2/3 of the ore get oxide. 2/3 of ore oxidized. Once 2/3, how do we know 2/3? That is spectroscopically we are determining the extracted gases, the waste gases we are analyzing. Okay. Then air flow is restricted. Now, as you can very well see, here the fumes, they are going to fall. The hot gases and the flame are going to interact with the ore. Fuel is not coming in contact with the ore. So airflow is restricted later. Now becomes calcination. But when the calcination takes place, this 2Cu2O, which has been formed, it reacts with the remaining part of Cu2s. Now this becomes reducing agent. This becomes oxidizing agent. And then what we end up with is we get 6 of Cu plus SO2. Now this is what we have as auto reduction. One part of the ore becomes the oxidizing agent, the other part becomes the reducing agent, and we do not need to use any of the other reducing agent. Okay. Now here the flux is silica. There is an impurity of iron in it. Iron sulfide impurity is there. That iron sulfide gets converted into iron oxide. Now this is the gangue, which reacts with silica, which is the flux, and it forms FeSiO3, which is the slag. Okay. In extraction of copper, silica is the flux. Any confusions here? Okay, fine. So that is the extraction of copper, and this is what we have as the auto reduction. Any problems, anyone? Now, we have talked about this part. Now, when we talk about till this part, it requires reducing agent. Now, the reducing agent which can be used for these particular elements could be aluminium, it could be silicon, but most often it is carbon. And sometimes it can even be carbon monoxide. So carbon monoxide, aluminium or silicon are used as reducing agent for these metals. When we talk about these metals, they are extracted electrolysis of molten salts. Is that clear? Now let's talk about the extraction using a reducing agent. Okay. But before that, let's talk about something called what reducing agent to use. And here comes a lingam diagrams. Now, what are these Lingam diagrams? The Lingam diagrams give the stability of oxides with temperature. They give the stability of oxide with temperature. Those are Lingam diagrams. Now let's see what these Lingam diagrams are. This is the diagrammatic representation of the Gibbs energy with temperature, how the Gibbs energy of a particular oxide changes as the temperature changes. Okay, so that's what the Lingam diagrams. Now, what we find is if we talk about this particular diagram, you can see that only one diagram is actually moving down. Here, when we talk about it, it is delta G is equal to delta H minus T delta S. Okay. The slope of the curve is minus delta S. Slope is minus delta S. So if we have the entropy change as positive, the slope will move down. But if we have the entropy change as negative, the graph will move up. And just remember, there is only one oxide. There is only one oxide where the slope actually moves down. And that reaction is carbon plus half O2 gives you CO, carbon monoxide. This is gaseous, and this is solid. So here we have 0.5 mole gas. Here we have 1 mole of the gas. So this is the only reaction of the formation of oxide where entropy actually increases. Otherwise, for the formation of any oxide, the entropy either remains the same, and that same is something like C solid plus O2 gaseous, forming CO2 gaseous. Now here the entropy does not change. The entropy remains the same. For all other substances, the entropy actually decreases. So everything else has a positive slope. Is this clear? Anybody who has not liked the session, go ahead and like the session. Any confusions, anybody? Okay, it was used by H.J.T. Ellingam. Now, one thing you need to understand, here we have the curves in the Ellingam diagrams for the formation of metallic oxides are straight line with positive slope because the metallic oxides, their stability decreases with increase in temperature. The lower the position of a metal in the Ellingham diagram, the greater is the stability of the oxide and more is the reducing power. Is this clear? The greater the gap between any two lines, the greater the efficiency of the reducing agent. So lower is the metal in the graph, stronger reducing agent it becomes. Is it clear? The stability of the metallic oxide decreases with increase in temperature. Then highly unstable oxide like silver oxide and mercuric oxide easily undergo thermal decomposition that we have already discussed. Anyone has anything to ask here? The positive slope of the metal oxide shows that the stabilities decrease with temperature. The decrease in stability is due to an increase in free energy change because delta S is negative for formation of oxides. The sudden change in the graph shows that it becomes more unstable. The oxide becomes more unstable with increase in temperature. And how does it become more unstable? Here, here you see it. Is that clear? Now, what happens here is here, magnesium boils. It gets converted into a gas. Its phase changes, and that's why the slope of the graph changes. Just remember, below this point A, magnesium is capable of converting alumina to aluminium. Above this point, aluminium can reduce magnesium oxide to magnesium. So the stability of magnesium oxide decreases with increase in temperature. Okay, and it becomes difficult for magnesium to act as a reducing agent. Is it clear? Now, there are limitations of a Lingam diagram. It does not take into any account of the kinetics of the reaction. That is, it does not tell anything about the speed of the reaction. Now, if there is more than one oxide, we don't know which oxide is formed. So it does not tell everything, but yes, it is very important. It is thermodynamics of metallurgy. Suggest a condition under which magnesium could reduce alumina. It is temperature less than point A. Same reason, as the temperature increases, magnesium reducing capacity decreases. And there will be an equilibrium which is established between magnesium and aluminium. These answers are given in NCERT. And now we are going to talk about the extraction of, let us say, iron from its oxide. Now, this is what we call as the blast furnace. एक काम करते हैं, मेटलर्जी की ना एक क्लास और कर लेते हैं, ठीक है? Now, this offer is valid for only today. Okay? This offer is valid only for today. So use the code AVLive and use this offer for our course. Iconic Mega Sale is working. Tomorrow at 2 p.m., Swati Batra ma'am is going to take Botany. 3 p.m., Zoology. Sachin Sir is going to take. 4 p.m., it's me, Chemistry. Join the Telegram channel, YouTube classes, PDFs, t.me/NEET Elixir. Here we have the NEET UG subscription. You can go on, go ahead, take it. And any of the subscription, use the code AVLive and you are going to get a discount. At this moment, it's a huge discount, but later, still you are going to get some discount. Unacademy.com/Anoop Vashishtha is the slide, the page on Unacademy where you can join with us. Subscribe the NEET Elixir by Unacademy. This is the Telegram channel where you get all the information. Thank you. We are going to meet a bit later in the special class at 8 p.m. The solid state. Bye bye. We'll meet at 8 p.m. Take care.